So, let us start the session now. We have discussed some theory of tangents and properties of tangents and relations and properties related to tangents and focus of a parabola in the previous lecture. Now, we are going to continue our problems. We solved one question in last class. Now, the second question, find the locus of the point of intersection of the tangents of the parabola y square is equal to 4ax which intersect at an angle 60 degrees. Let us take a parabola like this. If two tangents are drawn intersecting at an angle 60 degrees, then what is the locus of this point of intersection? That is the question. In our previous class, we have discussed about the slope form of the tangent of the parabola y square is equal to 4ax. The slope form of the tangent is y is equal to mx plus a by m. For any value of m, this line is a tangent of this parabola. Now, if this point of intersection of the tangents is x1, y1, let us assume that one of the two tangents is this line. If we substitute px1, y1, we get y1 is equal to mx1 plus a by m. Then multiplying by m on both sides, you will get a quadratic equation m square x1 minus my1 plus a is equal to 0. And already I have given this also as a point. The slopes of the tangents passing through px1 y1 to the parabola y square is equal to 4ax are the roots of this quadratic equation. You refer the notes, it is one of the theory points given in the last class. Now, if the slopes of these two tangents are m1 and m2, then what is the formula for acute angle between two lines? Tan theta is equal to, here theta is 60 degrees, so tan 60 degrees is equal to, what is the formula? Mod m1 minus m2 by 1 plus m1 m2. Now, m1 plus m2 is sum of the roots of this quadratic equation. m1 plus m2 is y1 by x1 and product of the roots is y1 m1 m2 is equal to a by x1. Okay. Now, we are going to simplify this condition. What is the value of tan 60 degrees? Root 3. So, if this is root 3, cross multiplying and squaring, we get m1 minus m2 whole square is equal to 3 into 1 plus m1 m2 whole square. Okay. Now, we have m1 plus m2 and m1 m2. You can write m1 minus m2 whole square as m1 plus m2 whole square minus 4 m1 m2. Is equal to 3 into 1 plus m1 m2 whole square. Then substitute m1 plus m2 and m1 m2. m1 plus m2 is m1 plus m2 whole square is y1 square by x1 square minus 4 into m1 m2 is 4 into a by x1 equals 3 into 1 plus a by x1 whole square. Now simplifying it, multiply both sides by x1 square, we will get y1 square minus 4ax1 is equal to 3 into x1 plus a whole square. So, if the angle between the tangents from a point p x1 y1 is 60 degrees, then the locus of p x1 y1 can be obtained by replacing x1 by x and y1 by y in this condition. Therefore, the locus of p is y square minus 4ax y square minus 4ax equals 3 into x plus a whole square. So, this is our answer. Okay. The same question can be asked in a different way. Same parabola, find the locus of the vertices of the equilateral triangles circumscribing the parabola y square is equal to 4ax. See, if a triangle is formed by 3 tangents of this parabola, then this is called a circumscribed triangle. Okay. And if this circumscribed triangle is equilateral triangle, then what is the locus of these vertices? Then the procedure is same, because the angle between acute angle between any two sides will be 60 degrees. So, you take any one vertex as px1 y1, then the acute angle between the tangents is 60 degrees and follow the same procedure. The answer is same. Okay. Next, question, if a tangent to y square is equal to 4a into x plus a is perpendicular to a tangent to y square is equal to 4b into x plus b, then the locus of their point of intersection is, options are given. The parabola y square is equal to 4a into x plus a will be like this, and y square is equal to 4b into x plus b will also be like this. Okay. The two parabolas are having axis along x axis. Now, if a tangent to one parabola, I will draw with black color, is perpendicular to a tangent to the second parabola, something like this, then the locus of the point of intersection of the tangents is, in this question, take a tangent to the first parabola in slope form. What is the slope form of the tangent of that parabola? We have already discussed in the previous lecture. If the parabola is y minus k whole square is equal to 4a into x minus h, the slope form of the tangent is y minus k is equal to m into x minus h plus a by m. This is the slope form of the tangent of this parabola. So, I will take tangent to the first parabola as y is equal to m into x plus a plus a by m, tangent of the first parabola. Let this be a tangent of y square is equal to 4a into x plus a. Okay. Now, we have to take a tangent of the second parabola which is perpendicular to this tangent. If the slope of this line is m, slope of the perpendicular line will be minus 1 by m. So, use the same formula, slope form of the tangent of this parabola with slope minus 1 by m. Then the tangent to y square is equal to 4b into x plus b is y is equal to, in place of m we have to take minus 1 by m, minus 1 by m into x plus b plus a by m. Here a is b, so plus b by minus 1 by m. Then what will you get? Y is equal to minus 1 by m into x plus b minus bm. This is equation 1, this is equation 2. The two equations are in terms of a parameter m. M varies. As m varies, these two tangents vary, the point of intersection moves on a curve and that curve is locus of the point of intersection. When the equations of two straight lines are in terms of a parameter m, then we can get the locus of their point of intersection by eliminating m or the parameter from the two equations. How to eliminate m from the two equations? We have to just observe and tell. If you subtract one from the other, subtracting from one another, y cancels, so one side will be 0, another side will be here mx minus of minus 1 by m into x, it will be m plus 1 by m into x. Next, plus here we have ma plus a by m, that is m plus 1 by m into a, and then if you subtract, this minus becomes plus, you will get b by m plus bm, that is 1 by m plus m into b is equal to 0. Then m plus 1 by m cancels and it cannot be 0. M plus 1 by m is never 0, so I am cancelling. So m is eliminated. Then what is the remaining equation? X plus a plus b is equal to 0. Okay. But in the options we have x minus a minus b is equal to 0. So this is a wrong option. Now let us check this option C. Is it equal inclined to the axis, x axis and y axis? No. If any line is equal inclined to x axis and y axis, its slope should be 45 degrees. Inclination should be 45 degrees or 135 degrees. So this line is a line parallel to y axis. So option C is wrong. Now coming to option B, is it the common chord of the two parabolas? You can observe that this same equation can be obtained by subtracting the equations of the two curves. If you take the curves as S and S dash, this equation is nothing but S minus S dash is equal to, S minus S dash means y square minus y square, one side will be 0, another side will be 4ax plus 4a square minus 4bx, 4by, 4bx only. Minus 4bx minus 4b square is equal to 0. You can cancel 4, then from these two you can take x common and write it as a minus b into x. From this and this, a square minus b square can be written as a plus b into a minus b. Now, we can cancel a minus b because a is not equal to b. If a is equal to b, the two curves coincide with each other. So, cancelling a minus b, you are getting the same equation. In circles, we have studied that if two circles intersect at 2 points, equation of the common chord is given by S minus S dash is equal to 0, where S and S dash are equations of the two circles. Equation of the common chord is given by S minus S dash is equal to 0. Similarly, in this case, that S minus S dash is equal to 0 is a straight line. What is that straight line? It is the common chord of the two straight lines. Not only in this case, in general, whenever there are two curves given, whatever be the curves, if the equation S minus S dash is equal to 0 is a straight line, then definitely it is the common chord of the two curves, because if the points of intersection are A and B satisfy both the equations separately. So, if we substitute A, first term S becomes 0, S dash becomes 0, so equation is satisfied. If you substitute B, the equation will be satisfied. So, this S minus S dash is equal to 0 passes through A and B. So, if it is a straight line, then definitely it is the chord AB. Okay. So, in this question, what is the correct answer? Answer is common chord of the two curves. Okay. So, if it is common chord, it cannot be common tangent. Next question. If the tangents to a parabola at P and Q intersect at R and S is the focus, then SP, SQ, SR, SQ will be in which progression? AP, arithmetic progression, geometric progression, harmonic progression and none. Here parabola is not given. Equation of the parabola is not given means it is for any parabola. So, we will assume that the parabola is in the standard form y square is equal to 4ax. Let the parabola be y square is equal to 4ax. Then this is origin vertex, this is x axis. Okay. Now, draw tangents at 2 points. Suppose this is one tangent and this is another tangent, P and Q, they intersect at R. Then if S is the focus, let S be here, then SP, SR will be in which progression? Let us assume that P and Q are in parametric form AT1 square 2AT1 is P, AT2 square 2AT2 is P, Q. Then what is the formula for point of intersection of the tangents? We discussed the formula in the last class. AT1 T2 comma A into T1 plus T2 is R. Then let us find SP and SQ. SP is equal to, SP is focal distance of point P. What is the formula for focal distance? It is mod x1 plus a. You refer the list of formulae, characteristics of this parabola, y square is equal to 4x. Focal distance of the point P is x1 plus a, mod. So here mod x1 plus a means AT1 square plus a. Since everything is positive, I will remove the mod. It is equal to a into T1 square plus 1. Similarly, SQ we can write directly as a into T2 square plus 1. Okay. Now, SR. What is S? Focus of this parabola a comma 0. For SR there is no direct formula, we have to calculate by using the distance formula. SR is equal to square root of a T1 T2 minus a whole square, that is a into a square into T1 T2 minus 1 whole square. Next, plus a into T1 plus T2 minus 0 whole square, that is a square into T1 plus T2 whole square. Okay. We can take out a square, it becomes a root, expand T1 T2 minus 1 whole square, we get T1 square T2 square plus 1 minus 2 T1 T2 plus T1 plus T2 whole square is T1 square plus T2 square plus 2 T1 T2. Now what happens? 2 T1 T2 cancels. Then what is the remaining? You can observe that it can be written in terms of these two. How? It is nothing but a into root over T1 square plus 1 into T2 square plus 1 in terms of these two. This can be factorized as this. Then SR square is equal to a square into T1 square plus 1 into T2 square plus 1. What is this? It is the product of SP and SQ. So we can write SR square is equal to SP into SQ. If SR square is equal to SP into SQ, then SP, SR, SQ will be in what? Geometric progression. Answer is second option. Next question. And also it is better to have this point in theory. Okay. It is just like a property because it is true for any parabola. Tangents at A, B, C on a parabola intersect at PQR. then area of the triangle ABC upon area of the triangle PQR is. Options are given as constants and equation of the parabola is also not given. Then what does it mean? It is the property of any parabola. What is the question? Take a parabola, draw tangents at ABC, 3 points. This is tangent at A, this is tangent at B, this is tangent at C. A, you can take this as B, this as C. Then they intersect at PQR. Let the intersection point of tangents at A and B be P, intersection points of tangents at B and C be Q, and this is R. Then the asked question is area of the triangle ABC. This area divided by area of the triangle PQR. The ratio of this area and this area is which constant? Equation of the parabola is not given. So, we assume the parabola as y square is equal to 4ax and get the answer. Let the parabola be y square is equal to 4ax. Then how do you take the points in parametric form? T1, T2, T3. T1 means AT1 square to AT1, T2 means AT2 square to AT2, similarly AT3, CT3. Then what is the formula for point of intersection of the tangents? P will be point of intersection of the tangents at T1 and T2 is A T1 T2 comma A into T1 plus T2. Q A T2 T3 comma A into T2 plus T3, and R will be A T3 T1 comma A into T3 plus T1. Now, let us calculate area of the triangle ABC. I will write the area as delta ABC. Delta ABC is area of the triangle ABC. What is the formula for area of a triangle? Half into determinant of x1 y1 1, x2 y2 1, x3 y3 1. Half into determinant of x1 y1 1. What is x1? Coordinates of A, AT1 square 2AT1 1. Coordinates of B, AT2 square 2AT2 1. Coordinates of C, AT3 square 2AT3 1. Let us simplify. You can take A common from first column and 2A common from second column. Then we will get 2A square outside. 2A square into half will be A square. A square into T1 square, T1 1, T2 square, T2 1, T3 square, T3 1. In determinants, you need to remember the value of this determinant 1a square, 1b square, 1 c c square. This determinant is called circulant, and this determinant comes very frequently in many questions. So, we have to remember this. The value of this determinant is a minus b into b minus c into c minus a. Similarly, if the first row is 1 1 1, second row is a b c, third row is a square b square c square, it is same. So, what is the value of this determinant? It is a square into t1 minus t2 into t2 minus t3 into t3 minus t1. Since it is area, we have to take mod. Now, let us calculate area of the triangle PQR. What are the coordinates? These 3. Now, I will take the area in the same form half into area of the triangle PQR is half determinant of coordinates a t1 t2 a into t1 plus t2 1 a t2 t3 a into t2 plus t3 1 and third row a t3 t1 a into t3 plus t1 1. We can take a common from first column, another a common from second column. So, we get a square by 2 into t1 t2 t1 plus t2 1 t2 t3 t2 plus t3 1 t3 t1 t3 plus t1 1. We can calculate this determinant by using row operations of a determinant. In any determinant, if you have 3 ones in a column or in a row, we should try to get 2 zeros in that row or column. After getting the 2 zeros, it will be easy to expand the determinant using that row or column. Here I am going to get 0 here and here by subtracting R2 from R1, R3 from R2. So, the operations that I am going to apply are R1 changed to R1 minus R2 and R2 changed to R2 minus R3. By applying these operations, you will get a square by 2 into determinant of this minus this will be what? T2 will be common. T2 into T1 minus T3. This minus this will be T1 minus T3. Here 0. Now, second row minus third row. T3 is common. So, T3 into T2 minus T1. This minus this will be T2 minus T1 0. Now, third row will be as it is T3 T1 T3 plus T1 1. Now, you can take T1 minus T3 common from first row and T2 minus T1 common from second row. It will be a square by 2 into T1 minus T3 into T2 minus T1 into remaining determinant is T2 1 0 second row T3 1 0 third row will be T3 T1, T3 T1, T3 plus T1 and 1. Now, if you expand using third column, 0 into anything 0, this 0 into cofactor 0 plus 1 into T2 minus T3. At the same time, we can modify these two as T3 minus T1 into T1 minus T2. And this will be T2 minus T3, this expansion. Since this is also area, we have to write mod, whole mod. Now, what is the ratio of this area of the triangle ABC and area of triangle PQR? If you divide this by this, what will you get? 2. Okay. So, answer is option C, and since it is the property of any parabola, it is better to remember this as a property. Okay. Next question, all of you should include this point and the previous point. What is that? This point in the theory notes. Now, the next question. Find the equation of the common tangents of the following curves. The first question is, two parabolas are given. One is y square is equal to 32x, another is x square is equal to 108y. Y square is equal to 32x is a parabola having positive x axis as axis like this. X square is equal to 108y is a parabola like this. Origin is their common vertex, axis of the first one is x axis, axis of the second parabola is y axis. Now, I want common tangent. You can easily observe that only one common tangent exists like this. This is the common tangent of the two parabolas, just observing from the diagram. Now, even without diagram, we can find the answer. In this kind of problems, we assume tangent to one curve in slope form, then you have to apply the condition for tangency to the second curve. I am solving the first question. Let the tangent to y square is equal to 32x be y is equal to mx plus a by m. What is a here? If this is 4ax, a is 8. So, y is equal to mx plus 8 by m. If it is tangent to this parabola also, if it touches x square is equal to 108y. We have already discussed the condition for tangency this parabola and this parabola. For this parabola, c is equal to a by m. For this parabola, the formula is c is equal to minus am square. What is that line? If y is equal to mx plus c is a tangent of this parabola, the condition is c is equal to minus am square. So, what is c here? 8 by m is equal to minus am square. What is a here? If this is 4a, a will be how much? 27. Minus 27 into m square. Then we get cross multiplying, we get m cube is equal to minus 8 by 27. Then m is equal to, taking cube root, what is the cube root of minus 8 by 7? It is minus 8 by 27, it is minus 2 by 3. Only one slope you got, that means only one common tangent exists, that already we have observed from the diagram. Now substituting this m in this equation, we get the answer. Therefore, equation of the common tangent is y is equal to minus 2x by 3 plus 8 by m is plus 8 by minus 2 by 3. What will get? Minus 8 by minus 2 by 3 means minus 12. That is all. Simplifying this equation, we get 2x plus 3y plus 36 is equal to 0. So, that is the common tangent of these two parabolas, first question. Now, we will solve the second question in the next slide, or we will solve separately here itself. In the second question, we have first curve parabola and second curve is a circle. We know the condition for tangency for both. Second question, let y is equal to mx plus a by m. What is a in this parabola? This is 16 is 4a. So, a is 4. So, mx plus 4 by m be the tangent of y square is equal to 16x. If it touches the circle, if it touches x square plus y square is equal to 8. What is the condition if a straight line touches a circle? Perpendicular distance from the center is equal to radius. Center of the circle is origin, radius is how much? Root 8, that is 2 root 2. Now, perpendicular distance from the origin to this line will be 4 by m by root 1 plus m square. It should be equal to radius. Radius is 2 root 2. Now, simplifying it, you will get the quadratic equation. It is not quadratic, it is biquadratic, but it is a quadratic in m square. If you factorize, you will get m square plus 2 into m square minus 1 is equal to 0. M square plus 2 cannot be 0, so we will cancel, we get m square is equal to 1. If m square is equal to 1, m is plus or minus 1. Then substituting m here, what are the common tangents? The common tangents are y is equal to plus or minus, taking plus or minus common, x plus 4. Next, in the third question, we take slope form of the tangent of y square is equal to 8x as usual. Y is equal to mx plus 4 by m. But this time we do not have a condition for tangency of xy is equal to minus 1. Okay. because already we have studied about circle, we could apply the condition for tangency, but here we have not studied about this curve. It is a hyperbola, we are going to study later. So, in this situation, when you do not have the condition for tangency, what to do? There are three possibilities. This is a straight line, this is a curve. A straight line and curve may be like this. The straight line may intersect the curve at two distinct points, or the line may not be intersecting or touching the curve, or the straight line may be touching the curve. Three possibilities are there. Then, if you solve the equation of the line and equation of the curve, if the line does not touch or intersect, then you will get imaginary roots. If the line intersects the curve at two distinct points, then you will get two distinct roots. If the line touches the curve, then it will have two equal roots. Okay. Now, I am going to solve the equation of the line and equation of the curve. That means just substitute y here as mx plus 4 by m is equal to minus 1. Then it simplifies to a quadratic equation m square x square m square x square, sorry, here if this is y square is equal to 4ax, a is 2. Now, after simplification, we get a quadratic equation m square x square plus 2x plus m is equal to 0. It is a quadratic equation in x. If this line intersects the curve at two distinct points, then you, by solving it, you should get two distinct values of x. If it touches the curve, then you should get two equal roots of x. What is the condition for equal roots? Discriminant is equal to 0. Delta is equal to 0. What is delta? B square minus 4ac. B square is 4 minus 4ac is minus 4m cube is equal to 0. Then we will get m cube is equal to 1. Taking cube root, we get only one root, m is equal to 1. That means there is only one common tangent of these two. Substituting m is equal to 1 here, what is the equation of the common tangent? Y is equal to x plus 2. This is the equation of the common tangent. Okay. Next question. A parabola has focus at 1, 2 and touches both the axes. Then find the equation of its directrix. Let us draw the curve. This given focus is in first quadrant, 1, 2 will be somewhere here. So, I am going to take the parabola in first quadrant touching both the axes. Let us draw a parabola carefully. Touching both the axes and having focus at 1, 2. Then it will have some line like this as axis. Now, what do you want? Equation of its directrix. Here, let us recollect the properties. related to what focus and tangents, because what is the given information? X axis is a tangent, y axis is a tangent, focus is given, that is all. And there are many points involved in this question. One is, if two tangents to a parabola are perpendicular to each other, then they intersect on the directrix. Here x axis and y axis are two perpendicular tangents, so they must intersect on directrix. What is the point of intersection? Point of intersection is origin. So, origin lies on the directrix. Directrix is a line perpendicular to the axis, so take the directrix like this. Okay. So, we got a point on the directrix. What else you need? For finding the equation of line, either you need 2 points or 1 point and slope. Already we got 1 point. We need either slope or another point. Which one is easy? Let us recollect another property about the focus and tangent. In the standard form, this is focus. Take any tangent. What are the points we have discussed? One is foot of the perpendicular from the focus on any tangent lies on the tangent at vertex. Another is reflection of the focus about any tangent lies on the directrix. Is it not? So, if you take reflection of this focus, this is the directrix. Now, if you take reflection of the focus about x axis, it should lie on the directrix. What is the reflection of the focus 1, 2 about the x axis? X axis is a tangent. Reflection of 1, 2 will be 1, minus 2. Definitely it lies on directrix. So, on directrix we have 2 points, 0, 0 and 1, minus 2. Then what is the equation? Any line passing through the origin will be in the form of y is equal to mx. What is m here? Slope of the line joining the origin and 1, minus 2. What is it? Minus 2 by 1. So, equation of the directrix is y is equal to minus 2x. Okay, it is finished. Now, I am going to discuss some more theory points Equation of the chord of the parabola s is equal to 0 bisected at px1 y1 is s1 is equal to s11. If px1 y1 is the midpoint of the chord where the parabola is s is equal to 0, equation of the chord is given by the formula s1 is equal to s11 in notation. Here s is equal to 0 need not be the standard form, it can be any equation, general equation. We can prove it by taking S as standard parabola. Let us take the parabola as y square is equal to 4ax. Then consider a parabola, consider a chord AB where A and B are x2 y2 and x3 y3. Then if the midpoint of AB is x1, y1, we have x1 is equal to midpoint formula x2 plus x3 by 2 and y1 is equal to y2 plus y3 by 2. Okay. Now, for getting the equation of the line, since you have a point, what else you need? Slope. What is the slope of AB? It is y2 minus y3 by x2 minus x3. Now, slope of AB is y2 minus y3 by x2 minus x3. Now, we have to get it in terms of x1, y1 because these 2 points we have assumed only the given point is x1, y1. So, we have to get the answer in terms of x1 and y1. Okay. So, we have to calculate this in terms of x1 and y1. For that, if A and B lie on this parabola, substituting A, we get y2 square is equal to 4a x2. Substituting B in the equation, y3 square is equal to 4a x2 x3. For getting this, what should we do? Subtract from one another. Subtracting from one another, y2 square minus y3 square is equal to 4a into x2 minus x3. Then LHS can be factorized as y2 minus y3 into y2 plus y3 is equal to 4a into x2 minus x3. So, from there, what is y2 minus y3 by x2 minus x3? If you divide this by this, you will get 4a by y2 plus y3. What is y2 plus y3 from this condition? 2y1. If we substitute 2y1 here, we get the slope as 2a by y1. If px1 y1 is the midpoint of a chord of the parabola, then the slope of the chord is 2a by y1. Then with this slope and the point, we can write the equation of the parabola. Equation of AB is y minus y1 is equal to 2a by y1 into x minus x1. If you simplify, you will get y1 minus 2ax is equal to y1 square minus 2ax1. Adding 2ax minus 2ax1 on both sides, LHS becomes S1, RHS becomes S11. That is how we get the formula. So, it is proved. Now, coming to the next second point, equation of the chord of the parabola S is equal to 0 joining the points x1, y1 and x2, y2 is s1 plus s2 is equal to s12. If one point is x1, y1, another point is x2, y2, then the equation of the chord is given by s1 plus s2 is equal to s12. Okay. Actually, it should be proved in circle. If you take the equation S1 plus S2 is equal to S12, S1 is a first degree expression, S2 is a first degree expression, you will agree. S12 is some constant term. So, first degree plus first degree will be first degree. So, this is totally a first degree equation. Any first degree equation represents a straight line. So, first of all, we have understood that the equation S1 plus S2 is equal to S12 represents a straight line. Now, if you substitute P in this equation, what happens? In S1, if you substitute point x1, y1, S1 becomes S11, S2 becomes S12. Then, since the point P lies on the curve, S11 is 0, then S12 is equal to S12 means the equation is satisfied. So, this line passes through P. In the same way, it passes through Q. So, this is the line passing through P and Q. This is the equation of the chord PQ. Okay. Just remember this sentence as a statement. We are not going to apply this as a formula in problems, it is just a statement. Okay. So, do not worry about the proof, I already explained, you try to understand it. Next is equation of the chord of the parabola joining two points in parametric form P of T1 and Q of T2. Very simple. P of T1 means AT1 square to AT1, Q of T2 means AT2 square to AT2. Then you have 2 points. We can find the slope of this line by y2 minus y1 by x2 minus x1 formula. So, slope is equal to 2a t1 minus 2a t2, that is 2a into t1 minus t2 by at1 square minus at2 square, that is a into t1 square minus t2 square. T1 minus t2 cancels, a cancels, we get this slope as 2 by t1 plus t2. Then equation of the chord is, using this slope and this point, we will get y minus 2a t1 is equal to 2 by t1 plus t2 into x minus at1 square. After simplification, the equation becomes 2x minus of t1 plus t2 into y plus 2a t1 t2 is equal to 0. All of you should remember this formula for equation of the chord joining 2 points which are in parametric form. Now, another point, if P of T1 and Q of T2 are extremities of a focal chord, if these two are ends of a focal chord, then the chord PQ passes through the focus A comma 0. Then the condition is T1 T2 is equal to minus 1, very important condition. Proof is very simple. See, in the previous statement, this is the equation of the chord. If it passes through the focus A comma 0, substitute A comma 0, 2A minus of 0, T1 plus T2 into 0 plus 2A T1 T2 is equal to 0. What will you get? T1 T2 is equal to minus 1. So, if P of T1 and Q of T2 are extremities of a focal chord, the condition is T1 T2 is equal to minus 1. But if you remember, the same condition is there for another theory point. What is it? If the tangents at P and Q intersect at right angles to each other, perpendicular to each other, the condition is T1, T2 is equal to -1. We have studied. That means tangents at the extremities of the focal chord intersect at right angles to each other. The converse is also true. What is the converse? If you draw two perpendicular tangents to a parabola, then the line joining the points of contact will be a focal chord. And also we have discussed another point. If two tangents intersect perpendicular to each other, they intersect on the directrix. This point of intersection lies on the directrix. So here tangents at the extremities of a focal chord intersect at right angles to each other on the directrix, or converse is from any point on the directrix, take any point, draw tangents to the parabola, then those two tangents will be perpendicular to each other and the line joining the point of contact will be a focal chord. You have to remember all these points. Okay. And one more thing, if the tangents at the extremities of focal chord are drawn, they intersect at right angles, and from this point of intersection, if you draw a perpendicular to this focal chord, the foot of the perpendicular will be the focus. Okay. So these are the points for today. So time is up. We are going to close the session for today, and we are going to continue some more theory points and then we start problems in this chapter. Okay, thanks for watching. See you in the next class.